Yeah, comes on everyone. Let's start off. The last thing we did with heat and thermodynamics, we have finished it. Today we'll be starting with a new topic, fluid mechanics. So if you see the whole chapter, right, there are two parts of it. There is a fluid statics and a fluid dynamics. The first part, fluid statics, is kind of like loss of motion. Primarily, it is about drawing an FBD and solving. So you will see a lot of resemblance with that, with the FBDs and stuff. And the second part will be mostly like based on energy conservation. So let's go ahead. So when we say fluid mechanics, first let's define an ideal fluid. So what's an ideal fluid? Any substance that cannot withstand tangential force is called a ideal fluid. A more technical name is shearing stress. So we will see about this in elasticity. So if a substance cannot withstand tangential force, we say it's a fluid. So what do you mean by that exactly? Let me take you an example. Let's say if you have a stack of books. Let's say all surfaces are rough. Now, if you try to apply force here, this is what you will notice. Something like this. So if you apply force F on this, there will be friction on the upper book in the backward direction. Friction will be forward, friction will be backward, and so on. So here you will observe the friction opposes the horizontal force or the tangential force. So here, if you see, there is an opposition to the horizontal motion here. So if you try to drag the books, maybe it won't happen like this, but the books will actually oppose something. You won't be able to pull them that easily. So this is what you're saying. So there is an opposition. There's a resistance, or whatever you want to call it. Now, same thing if suppose friction was absent. Then you will notice you can even apply force on the middle layer and still the books move like this. Meaning, see, if I apply force on the middle book, you can see only that book slides. If you apply force on the upper book, only the upper book slides. Making sense? So if there is no friction anywhere, whichever book you pull, only that book will come out, and remaining all will be in its respective places. If you see here, there is no opposition to the horizontal force. So there is no opposition to the force parallel to the surface. So you can think of, even when you say liquid, a liquid is not one single substance. You can treat it like, it is made of different layers. Kidding? I mean, if you ever drink a, mojito or something like that, you must have seen that all that syrup and everything is at one layer. The bottom part is something, the upper part is different layer, different layer. You can have different layers in that. So there's no opposition for, to the force parallel to the surface. So this is what we call as tangential force. So an ideal fluid will kind of behave like this. It's like a stack of books without any friction. You try to pull any one book and they're like fine, matlab. There is the other books or anything other layers don't oppose the motion in the horizontal direction. Kind of making it sense. Making sense. Just an analogy. So you can think of fluid like it is made of different layers. So whenever you try to apply a force parallel to the surface, an ideal fluid won't resist. It will just the layers will just drag off. Clear with this, everyone? So one thing is clear from here. So if you apply a force parallel to the surface, you can't withstand. But what if I apply force perpendicular to the surface like this? The books are okay with this, right? You're just trying to compress the fluid. Nothing happens. So that is okay. So you can have a force perpendicular to the surface, but you can't have a force tangential to the surface or parallel to the surface. Is that making sense? Because when you apply perpendicular to the surface, you're trying to compress the layers. The liquid will resist you, but parallel, there is no force between them. So if you take a container, right, and let's say if you apply force at an angle theta. So let's say somehow I applied a force F at an angle theta here. So the vertical component will be F cos theta, and this component will be F sine theta. What do you think will happen? The F cos theta, there is no problem, right? You're compressing the liquid. But what does F sine theta do? If you apply force tangential to the surface, what will happen? The layers will go to the right side. That means the layers from the left will start going like this. Doesn't make sense? Isn't this what will happen? If you keep moving these layers from left to right, the liquid on the left will decrease, liquid on the right will increase. If you are continuously dragging. So when you do this, so here this F sine theta pushes the liquid to the right. So when you do this, you change the shape of the surface. This will happen till when? Till the force becomes perpendicular to the surface. Meaning this is how it would look. The liquid will eventually, right, become like this. And the force F becomes like this, perpendicular to the surface. This will be your surface. Is this making sense? No, the thing is that way. If the force is not perpendicular to the surface, the argument is like this. Again, listen. If the force is not perpendicular to the surface, that means there is a component parallel to the surface. If there is a component parallel to the surface, since there is no friction between the layers will move. If the layer moves, right, the surface shape will change. This has to keep on happening till there is no horizontal component or there is no parallel component. Making sense? So eventually the force has to become perpendicular. So from here we can make a statement. The net force on a perpendicular on a liquid surface is always perpendicular to the surface. If it is not perpendicular, the tangential component will drag the liquid till it becomes perpendicular. Like here, one thing is important. When you calculate the net force, always calculate with respect to the container. That means keep your observer on the container. So you have to include the pseudo force if the container accelerates. Calculate the net force with respect to container. That is, include pseudo force if container accelerates. There. Have a look at this. That is an important statement. So all the story that I was telling from last 10 minutes, it all leads to one statement. If you have a liquid surface, do whatever you want. The surface net force on the surface has to be perpendicular to the surface. Is that clear, everyone? So let me show you some examples. Clear with this? So going ahead, Devansh, Arnav, Arush, Daksha, Jainil, Vignajit, Soham, clear? Surya, Sharma. So let's take an example. So if you have a container, you fill it with liquid. Container is at rest. So how will the liquid look like? This is kind of obvious. So if you look at this surface, if you look at the net force on the liquid surface, again, there is only mg. We are drawing only for the liquid surface, perpendicular. So that is fine. How does this look like? Suppose if you have an incline, theta, and if you take a container and if you keep it at rest, now if you put liquid in this, how will the liquid look like? The liquid will still look horizontal like this. The reason? Same thing. The only force acting on the surface is mg. So the surface will look like this. Right? What about this case? Let's say we have an incline, theta. We have the container. Let's say this is smooth. So if you put a smooth container on a smooth surface, we know the acceleration will be g sine theta. It is dragging, sliding on the floor. Now, if you put water inside, what will be the shape? If you have a container on a smooth surface sliding with g sine theta, and now if you put liquid in this, how will that liquid look like in steady state? Right? See, again, what did I say? First, let's draw the FBD of the liquid surface. So take our observer and make him sit on the container. That will be more easy to see if you stand on the container. So this is your incline. So if you look at the forces, this would be mg sine theta. This would be mg cos theta. Now, if the container is going to the done, how is the pseudo force? Mass of the liquid and acceleration in the opposite direction. So that would be ma, which is mg sine theta in the backward direction. Make sense? So if you calculate the net force, the mg sine theta component cancels, and you'll be only left with mg cos theta. There, this is the net force on the liquid surface. So your liquid will look like this. The liquid will be parallel to the incline, and the liquid will think the net force is mg cos theta. This would be the surface. Is this making sense, everyone? Meaning, if you actually try to think about what's happening, see what is happening. Suppose if you just keep the container here, this is going with what? G sine theta. Suppose somehow, if you can keep the liquid only here, liquid also will go with G sine theta. So every time this liquid is trying to go and touch the container is also running away with the same acceleration. You're getting it? Suppose if the container was at rest, what would have happened? The liquid here will go and touch the container and it will become like this. It will get tilted. So here you're trying to chase the container, but the container itself is going with the same acceleration. So in the ground frame, it gives you a feeling like, both are going with G sine theta, so it remains just flat with respect to the incline. Clear with this? All clear with the examples? Abhinav? Arush? Arya? Clear with this? Ahana? Ansh? Clear? Great. Let's see a question then. Remember, I taught you only one thing till now. The net force on the liquid surface must be perpendicular to the surface. So we have an incline, theta. Let's say it has friction, mu less than tan theta. That means the container will slide. We have a container here. The fluid will be somewhat like this. So what I'm asking is, if this was the surface, that is alpha, find angle made by the liquid surface with the horizontal. Hmm. The previous case I showed you was a smooth surface, but now our container is not going to go with G sine theta, it will have something less. Now, what is the angle made by the liquid surface with respect to the horizontal? I hope the question was clear. If you put mu is equal to 0, I should get the previous answer. So theta is given. You have to give me the answer in terms of all that stuff. Mu is given. Mere purvaja. Meaning you didn't get theta of the incline, didn't matter only. So if you put mu 0, what should you get? Tan theta minus mu. Okay, let's see. First of all, if you keep something like this on an incline, you should know the acceleration. This comes from friction. The mass won't matter anyway, it'll get cancelled. Because it is sliding, this is F max. We know this is going to accelerate with g sine theta minus mu g cos theta. This is the first thing you should know. No, let's see. This is theta. Now, if you look at the forces, we have this is mg sine theta. This is mg cos theta. Same like previous one, the pseudo force will be backward ma, which is nothing but mg sine theta minus mu mg cos theta. So if you try to find the resultant of this, so this blue line is your incline. The net force would be, this would be mu mg cos theta. So mg sine theta will cancel, get mu mg cos theta. We will get this thing as mg cos theta. So the net force will be something like this. This black line is your net force. So your liquid surface should be perpendicular to this black line. So this would be 90 degrees. This was your alpha. This was the surface, the green one. This was theta. So this was 180 minus theta. If you take this angle to be some beta, tan beta is opposite side, mu mg cos theta by mg cos theta. So tan beta is equal to mu. If that is beta, this is 90 minus beta, and this is again beta. So the sum of the angles in that triangle is alpha plus beta plus 180 minus theta is 180. Therefore, we get alpha is theta minus beta, which is theta minus tan inverse mu. Check. Again, what did we do exactly? Step one, we found the acceleration from friction. Second, we draw the FBD with the pseudo force. Third, we resolve the forces. And then we said the only time we used fluid mechanics is where we said the surface is perpendicular to the net force. Bus. But if you see the whole thing, the whole question we did, we just drew an FBD and we did geometry, isn't it? Have a look at this. It's a pretty good one. And if you put mu 0, meaning it will slide on a smooth surface, we'll get alpha is equal to theta. Makes sense? The surface is parallel to the surface. Incline. Any doubts on the steps? Clear? Next one. Niharika, clear with this? Devika, got this? Abhinav, Janil, Ojas, Abhinav, clear? You got stuck, I guess. Okay, next one. Any doubts on this? Next one, let's say we have a cubicle container. This is an open top, so it is not closed. So on the top, it is open. It's a cube which is half filled. This is L by 2. And now what you did, you started accelerating this cube. Container accelerates horizontally with A. So you need to draw the shape of the liquid. So how will the liquid inside look like? Draw the shape of the liquid surface and the amount of liquid that spills out. So if you really accelerate fast enough, there is a possibility the liquid will come out of this open top. Now we will do this for three cases. So case one, when A is G by root 3. Case 2, when A is equal to G. Case 3, when A is equal to G root 3. There are three different questions. So if the acceleration is G by root 3, draw the shape of the liquid and the amount of liquid that spills out. A is equal to G, shape, liquid spills out, G root 3. Three different questions. Get them. I hope the question was clear. Think. I'll give you a minute. At least get the basic thing. Again, the story is still the same. Stand on the container, find the net force. The liquid surface has to be perpendicular to that. And remember, till now, I just taught you only one thing. Whenever the net force acting on the liquid surface is perpendicular to the surface. That's it. Hmm. So let me show you this. So when you take this container here, and if you're accelerating with A this way, what are the forces acting on the surface? One, the pseudo force. This would be Ma. The other is your Mg. So this is what the container, the person on the container will think. So the net force will be something like this. So basically, your liquid surface has to be perpendicular to this black line. So this was in 90. So if you take this angle to be theta, this angle will be theta, this angle will be theta. So from here you can clearly see tan theta. So this is Ma, this is Mg, This was theta. We can see tan theta is equal to MA by mg. You can actually remember this result. Tan theta is equal to A by G. It's a standard result. This itself is the mains question. So the thing about this is it really doesn't matter how you take the container, meaning you can take some amoeba shaped container, and if you accelerate with A, you can be sure the liquid inside here will make an angle theta like this. You take any shape of the container, do whatever you want, it doesn't matter. It will make tan theta is A by G is valid. So coming back to our cases now, case one, A is G by root 3. We get theta is 30 degrees. So the liquid will look like this. The liquid will not spill. This will make an angle of 30 degrees. Case 2, when A is equal to G, theta would be 45. This was a limiting case. Since it is a cubical container, exactly at 45, you will be on the verge of spilling out. Since you said half filled, this is also half filled. So in both these cases, there is no spillage. So if you exceed 45, now the liquid is going to spill. So can you draw how will A is equal to G root 3 look like? Try, I'll give you a minute now. So how do we know it doesn't spill? Because I know up to 45, you won't reach the topmost part of the container, isn't it? Only once you exceed 45, the liquid is going to spill now. So till 45, you're safe. So if you exceed this, now can you draw the shape of the liquid and how much will it spill out? Yeah, theta will be 60, but how will you draw that? Hmm. See, now the problem is, how will you draw 60 degrees now? Now, one way of putting it is, you can't have a 60 degrees like this, right? This doesn't make sense. Liquid is going to spill out. So the thing is, there's a limitation. You can't change the height of this thing. The height is fixed, but you still want 60 degrees. Then there's only one possibility: change the base. This is 60 degrees. This is L. This is L by root 3. Means you're accelerating so fast. In this region, there is no liquid. The entire bottom part of the container gets exposed to atmosphere. So if you actually look at the shape in a three-dimensional, this kind of looks like this, isn't it? It's like your half sandwich. If you ever seen the sandwich, so kind of like this. So this is L, and this is how it will look. So what is the final volume? So some part of the liquid will get exposed here. The final volume is area of the triangle into width. That is half into height into base into the other one. So, and the initial volume, it was half filled. It was L cubed by 2. So volume spilled, subtract them, which is L cubed by 2 into 1 minus 1 by root 3. Check. So once you exceed 45 degrees, you are going to spill out. This is how the shape will look. Is the shape making sense, everyone? So you can't increase the height of the triangle, that is fixed L. So, yeah, but still you want 60 degrees, there's only one possibility: increase the base. Make sense? Any doubts on this? Let's see one more. Clear, Parth? Parth, clear with this so far? You're not clear? Which part? You are late to the class. Yeah, should be on time.
What we did for final volume.
I just took this area, this volume. You find the area of the triangle into the width, right? Area into width will give you volume now. What is the area of a triangle? Half base into height into width. Sure. Yeah. Ask me if you're confused. At least message me in the chat box here to the co-host. Don't just keep waiting for me to ask you if there's a doubt. If something you're not clear, please don't hesitate to ask. Get it cleared. Next one. The small things. Till now I just taught only one concept. That if you have a liquid, the net force will be always perpendicular to the surface. That's it. I didn't teach you anything else. And the net force is what? You take all the forces, draw the pseudo force and everything, and find the net force and finish it off. And let's see. So we have a container filled with liquid. This is small h. Capital H is the total height of the container. This is the radius. Now what you did, you started spinning this liquid. With omega. This is how the liquid surface started becoming. So you get a curve like this. You must have seen this, right? When you put a thing, case2 here, there. Have a look at this. Clear? So this becomes the height, let's call it h1. So from this bottom here, this becomes h2. It kind of looks like this, a bowl kind of shape. First one, find the equation of the curve. So basically, I wanted to find the equation of that surface. So you put water in a bucket and rotate, or if you take a glass of water and rotate with a spoon, this is what you will see. And find h1 and h2. Let's get this. This would be an advanced paragraph. Meaning I can even ask you more questions. Find the condition if the liquid does not spill out. Find the condition if the bottom part of the container is exposed. Means if you rotate really fast, there is a possibility you can see the bottom of the container. If you rotate really fast, there is a possibility liquid will start going away from the sides. So you can ask multiple things, but where all that you need h1 and h2. Janil, that means independent of omega, this is the answer. So if omega is 0, you should get that answer, right? Sense one, right? You're getting an answer without omega. That means even if I don't rotate, you get a shape, whatever you said. So also, please use Arthka Max. Don't use alien concepts. Again, remember, I taught only one concept till now. The net force on the liquid surface is perpendicular to the surface. That's it. And here, we have an advanced paragraph question. They didn't even start the chapter. Think. Take a minute for the equation. Then I'll give you more time for the second part. Right, Vihan. That would be the equation. Get the second part. नहीं रे अंश, ओमेगा hey, you goofed up something. What a straight line. Or maybe you typed it wrong. I don't know. You got omega to the power of r. Well, that is quite interesting. Yeah, but that is wrong. You got a straight line. Something maybe you typed wrong. Check it out. Not power into. Okay. Still wrong. Dimensions से match में नहीं हो रहा है. Let's see. Now, if you take this shape, if I take this point as origin, if I take this point as x comma y coordinate, so this particle here is going in a circle of radius x. Now, if you're going in a circle, what are the forces acting on the system? The centrifugal force dm omega square x, your own weight dmg. Again, we are just drawing the forces of a particle on the surface. So the net force will be resultant of these two. This is your F net. So your surface has to be perpendicular. Here the surface meaning the tangent. So if you take this angle to be theta, this angle to be theta, this angle to be theta, we will get tan theta is dm omega square x by dmg. So we get tan theta is nothing but omega square x by g. This is nothing but slope. And we know slope is nothing but dy by dx. Isn't it from calculus? The slope of a tangent is first differential dy by dx. So we get dy is equal to omega square x dx by g. Integrate 0 to y and 0 to x. We get y is equal to omega square x square by 2g. This is a parabola. In 3 dimension, we call it paraboloid. Quite a useful one, a proper mains level question if they just ask you the equation. If I ask you h1, h2, suddenly it becomes an advanced one. You're supposed to integrate. So, is this making sense, everyone? So every particle here is going in a circle of different radius. So take any random particle at x comma y. It is going in a circle of radius x, centrifugal force d by omega square x and dmg. From there you got tan theta, and tan theta is dy by dx. This is one thing, remember in physics, at least whenever they ask you equation of the surface, always somehow find tan theta using physics and then write tan theta is dy by dx and integrate. That is the only way you'll get an equation. This is clear, everyone. Any doubts on this page? Now the second part of the question, initial height of the liquid was small h. Now if you spin this liquid, find h1 and h2. And this is not the first time you're seeing this. Anyone remember where you've seen this? Calculus, volume of a paraboloid. And then we proved something here. This is the result. The volume of a paraboloid is half of the volume of the cylinder which it encloses. This is the result you will need. Without this result, you can't solve. Have a look at the result. If you have a paraboloid here of height h and radius r, the volume of the red one or volume of the blue shaded part, whatever is remaining, is half of the volume of the cylinder, half into pi r square h. Anyone remember this? This result you should know. This comes from calculus. In case you don't know, you have to derive in the exam there. You need this result. Half of the volume of the cylinder. No, assume the water doesn't spill. We will see that condition for that later on. We will find the condition when it will not spill. So now can you solve this? Just to give you an idea there. This is the liquid. This was H2. This was H1. This was R, and we have taken this point as origin 0, 0. And just now we derived omega is equal to omega square x square by 2g. There, you have this much information. And we know the paraboloid volume is half of the volume of the cylinder it encloses. Now can you find H1, H2? Try, I'll give you 2 minutes. Okay. Bihan got it. Let's see others. Try. 2 minutes. Hmm. 6H आ गया ना आज. मतलब if you put omega 0, the height of the liquid is 6 times H. You have created more water out of nothing. You're Jesus Christ. You got free water. We should send you to Sahara Desert or Thar Desert. You are the savior. Pi r square h omega square by 2. What is this, Puruja? H1 or H2? Simple way to test it. If you put omega 0, you should get H1 is equal to H2 is equal to small h, isn't it? That's a simple way to test. Okay, it was H1 minus H2. So here, look at this thing. So when you took this parabolic equation, if you take this as your origin, this height here was H1 minus H2. And this was your radius. So this corner ka coordinates are r comma H1 minus H2. So if you substitute here, you will end up with H1 minus H2 is omega square r square by 2g. This is equation 1, everyone. This comes from the equation. The difference in height is omega square r square by 2g. Next thing, conservation of volume. Because we are assuming the liquid is not spilling out. Initial volume is equal to final volume. So what is the final volume? The final volume, there are two parts here. This was the paraboloid. So we need this volume plus we need this volume. Agreed? The shaded part. This height here is H1 minus H2. This was radius. This was radius and this was H2. So this volume will be half into the volume of the cylinder pi r square into H1 minus H2. Plus this will be pi r square H2. When I add them, I end up with pi r square H1 plus H2 by 2. That is your volume of the total thing. So what is the initial volume here? Initial volume is pi r square h, the initial volume. The final volume is pi r square by 2 h1 plus h2. So from here we will get h1 plus h2 is 2h. This is a pretty good result to remember. Even in case you don't know that, this parabola and all that stuff, you can still remember. So from this, if you can solve this, equation 1 and equation 2, we will get h1 is equal to h. Add them, so that will be omega square r square by 4g. We get h2 will be h minus omega square r square by 4g. Now, in case you forgot about this, volume of paraboloid is half of volume of cylinder enclosed. This you can, this was at page 113 calculus. Check. Being the second equation, right? By chance, let's say paraboloid and all that you don't remember, it's still a very easy result to remember. The sum of the heights will be the 2 times the h. Have a look at this. So volume conservation and the equation. Are the steps clear, everyone? Equation 1 is clear. The y coordinate will be the difference in height and the x coordinate is the radius. The second is the volume conservation. Since the liquid is not spilling out, the total volume must be remaining constant. Now they can add further more question. They can ask you find omega if the liquid spills out. Now for to spill out, what should happen? If the liquid has to spill out, then the H1 should be greater than or equal to capital H. Isn't it? If H1 is greater than capital H, the liquid will spill out. So H1 is H plus omega square R square by 4G is greater than H. So we get omega must be greater than 4G H minus H by R square ka root. If you exceed this omega, the liquid is going to spill out. So this is another way of asking questions. In the paragraph, they can ask multiple things. For bottom to be exposed, again, when I say bottom to be exposed, this is what you are saying. You are rotating so fast, the liquid becomes like this, meaning the parabola is actually going below the surface. So this part is getting exposed. So indirectly, H2 has become negative. So if H2 becomes less than equal to 0, you will get exposed. So this is H minus omega square R square by 4G. So omega ka value must be greater than equal to 4G H by R square ka root. Is this making sense? So further questions could be asked. But do have a look at the derivation. So again, see, we started from here. Take a point x comma y. The net force acting on the particle is the centrifugal force and mg. Then we got tan theta from there, which is dy by dx, the slope. Then we integrated, we got the equation. This page is clear, everyone? Parth, clear with this? This is clear, no? Jainil, Daksha, clear? And then we said, okay, we know the equation of the curve. So height of that parabola is h1 minus h2, and the x coordinate is r. So we got one equation from the equation there. And the second thing came from volume conservation. So now, in case you don't know this paraboloid volume, you will get stuck. So this you should know. You can actually integrate this. In case you forgot, go back to the calculus and check it out. Once we got this, we have done two equations, two unknowns solved, we got the answer. What we have taken small h is given. Small h is the initial height of the liquid. Right? Capital H is the height of the container. So this was actually useless, capital H, until you asked me when will the liquid spill out. That is the only time you'll use capital H. Or else if you just ask me H1, H2, I don't need capital H. Clear? Small h was the initial height of the liquid. Please have a look at this page. Ask me if you're confused. And then this part is fine. So liquid that spills out. So you want to spill out, exceed the height of the container. You want the bottom part to be exposed. But everyone got the meaning of this bottom part to be exposed. You rotate so fast, you can see the bottom of the container. Clear? Yeah, that's how they can frame a question. And if you see till now, I just taught you only one thing. The net force is perpendicular to the surface. And you can see the type of questions you can get. Clear, na, Devansh? Ahana? Nikhil? Clear. Next thing. Now, in NLM, right, when we studied, if you see F is equal to MA, right, we are more interested in finding the forces and masses and accelerations. But now in case of fluids, right, we have an issue. If I take a container, small container, and if I take a big container, and if I fill with water, mass will change, but what remains same? The density, isn't it? You take 1 liter of water and take 1,000 liters of water, mass will change, but density remains same. So whenever you study fluids, it's more preferable if you study in terms of density rather than mass. Same way, instead of studying in force, we study in terms of pressure. So, like I said, it's really not that different from NLM. The only difference, the kind of quantities we study is different. Think about it. Tomorrow, if you go to a real estate agent and ask him for a house, does he come to you and say, this is a nice 3 BHK, which is 0.2 acres? Right? They don't say that way, isn't it? He will say, boss, it is like 1,600 square feet or 1,400 square feet. So they sell you in terms of square feet. Same way, when you go to a shop tomorrow and if you ask, did you ever went to a hardware store and buy nails? Next time when you go and Zena, you know how they sell you? They sell you in kgs. If you go to them and ask them, give me 20 nails of so and so size, they will take the nails, they'll put them in a machine, they'll measure the weight and they'll sell you. Because for them, the shape doesn't matter. What they're selling you is weight of the metal. Even same thing, if you go and ask them, give me half-kilometer copper wire, they'll put it in a machine. Most of them won't understand what is half-kilometer. They'll ask you how many kgs you want. So they'll put that wire in a weighing machine and they sell you in kgs or grams. Getting it? So the shape is like a consolation price. What you are actually buying is the weight of the metal. Same way, so we prefer density. Symbol is rho. So density rho is given by mass by volume, straightforward definition. Now, few values you need to remember. Sometimes they'll give, but there are some exams we won't get this. So 1 gram per cc, standard result, which is 1,000 kg per meter cubed. It's actually pretty heavy. Yeah? We don't realize this. For example, the room you're sitting in, meaning the room I'm sitting in, I measured it yesterday. It was something like 5 meters length, maybe 6 meters breadth, and maybe 4 meters height. So something like 5 into 4 into 6, something of this sort. How much is this? That's 120 meter cube. If you fill up my entire room with water, that gives you a weight of 120 tons. Your floor will collapse if you fill it with water. So that is the reason why people don't build swimming pools on top of a building. It becomes a lot of effort. You have to strengthen the building, lot of cost, and also swimming pools are generally on the ground level, right? And so be careful here. Sometimes you might get a weird idea like, let's make my room into a swimming pool and you fill it with water. right? You fill it with water, the floor will collapse, and niche ka floors will get a shower only. So this is 900 kg per meter cube. The another liquid which you should know is raw mercury. 13.6 gram per cc. Cc is cubic centimeter, which is 10 power minus 6 meter cube. 13,600 kg per meter cube. This values, just remember them. But sometimes they won't give you density. They'll give you in terms of called specific gravity. Specific gravity is relative density with respect to water. So example, if someone tells you the specific gravity of gold is 19.3. That means density of gold is 19.3 times the water. Gold is pretty dense. And most movies get this wrong. You know how big is that actually? Do you have a water bottle in front of your 1 liter one? Generally, we all use 1 liter water bottle, right? Imagine, right? You're going on the road and you find 5 gold bars of that size. Or let's say you have 5 gold bars like that in the shop and someone is trying to steal it. Can you take those 5 gold bars and put it in your bag? You know what will be the weight of each one? You're rich, that is fine. But before that, what happens? Let's see. You have to steal them, na? Maybe stealing back here. If you see that 1 liter of the gold bar, right? 1 liter water is how much? 1 kg? 1 liter of gold will be how much? 19.3 kgs. If you have into 5 bars, this is approximately 100 kgs. Do you really think you can put 100 kgs in the bag and run? Forget about 100. Even catching the one gold bar and running, it's not going to happen. Meaning the water bottle which you are catching, uska 1/20th of that piece is actually 1 kg of gold. Getting this? So most of the shows now they get it wrong. They bring a car and bloody they fill up half the car with gold and they just run away like nothing happened. Your car ka wheels will just collapse. Right? Just imagine like this thing. You try to lift a gold bar of 1 liter ka thing, it's 20 kgs, and putting 5 of them in the bag and you're trying to run. What are you, Arnold Schwarzenegger? Right? You're not going to run with 100 kgs anywhere. It's a pretty bad way to steal gold. But if you have seen that series, right? What is that thing? वो है ना वो स्पेनिश वाला सीरीज forgot the name जो भी है in that you see they don't steal the gold bars, they melt the gold and make it into a small things and then they export all that stuff. A money heist, right? That is the thing there. At least they got the science right because they got a professor anyway, so it works. So variation of density, this we have seen in thermal expansion. So the new density will be the old density by 1 plus gamma delta T. Gamma is your coefficient of volume expansion. You have that special case, anomalous expansion of liquid. We have that in thermal expansion, so we'll leave it. Okay, that's a bit about density. You'll make a pit and you'll keep it and then you'll take a gold bar every day. Nice idea. Clear with this? Nah, you guys think that way, but imagine really find a gold bar. More than getting gold, nah, you will be in a hell lot of trouble. You can't sell it. What will you do? You'll go to the shop and you'll say, have a 20 kg gold bar, give me money. First thing the shopkeeper will say, I'll call the police. I'll get you arrested. Then he will say, ठीक है, I'm a good person. I'll give you 1 lakh. Just give the gold bar and shut your mouth and leave. What will you do? You'll go and call the police. The police will come and beat you right in the face and say, where did you steal the gold bar from? And they'll take the gold bar. You know what is the most difficult part of robbing a bank. It's not stealing the bank. Stealing the bank is easy. The problem is keeping your mouth shut. And that is how people get caught. But anyway, robbing a bank is the most useless thing you can do. If you actually should go to a bank and try to withdraw 10 lakhs, they will say, sir, we don't have money right now, come later. They really don't have money. Banks don't have enough money. So if you want to really go and withdraw, you have to tell them 4 days in advance and they'll bring the money from somewhere and then they will give it to you on that day. That is an interesting part. Anyways, next thing. Two liquids of density, rho 1 and rho 2 are mixed. Case 1, you are mixing same volume, matlab 1 liter of liquid rho 1, 1 liter of liquid rho 2. Case 2, same mass, 1 kg of liquid rho 1 and 1 kg of liquid rho 2. What is the average density? You have taken two liquids and you're mixing them in same volume. What is the average density? If you're mixing in same mass, find the average density. Get it? It's an easy one. Let's see. Yeah, looks like J-Men's these papers are out. People started messaging their marks. One guy got 96, one guy got 95 so far. Physics may out of 100. Let's see. So the first case, rho average, is nothing but total mass by total volume. So total mass will be rho 1 V plus rho 2 V density into volume by total volume is V plus V, which is rho 1 plus rho 2 by 2. In the second case, it's a total mass. So I'll take it as mass as M, and volume will be mass by density is volume. We get 2 rho 1 rho 2 by rho 1 plus rho 2. Clear? If you see this kind of, it looks like kinematics. Remember, there's a problem. Find the average velocity when a vehicle is going with same speed for same time, different speed for half that distance. Kind of looks like that. Clear this, everyone. That's a bit about density. In the next one, instead of force, we prefer to study in terms of pressure. Any doubts on this page? Going ahead. So pressure P. So you need to first of all see, like, why do we even get pressure in the first place? The thing is, when a body is immersed in a fluid, or even when you're sitting in an atmosphere right now, the molecules are continuously colliding with you. When a body is immersed in a fluid, the molecules collide. with the surface, generating a force along the common normal. This force perpendicular, this force per unit area is called pressure. So at a fundamental level, pressure is nothing but molecular collisions. So if you take any random surface like this, and if you look at the molecules, so it goes here, it hits here. It doesn't matter how the molecule collides with the surface. Let them collide at any angle. We know in an oblique collision, the force will be always along the normal, isn't it? Because there is no tangential force, there is no change in momentum in the horizontal direction. So basically, these are oblique elastic collisions. So therefore, you can be sure. Now, people say this statement, the force due to pressure is perpendicular. Technically, it is wrong. The way you defined as the perpendicular force by unit area is called pressure. Are you getting it? So obviously, the force has to be perpendicular. Are you getting the difference? They might look the same, but they're not. It's like saying you look like your parents look like you. Both the statements look similar, but they're not. Getting it? You look like your parents, they don't look like you. So the same way, the definition, by definition, if you see it is defined, the force is perpendicular to the area, that is called pressure. So, but in books and all, you will see as if the pressure will always exert perpendicular force. It doesn't make sense, but okay. Mathematically it works. So the force due to the pressure is always perpendicular to the surface. So it doesn't matter what kind of shape you take and put it in a liquid, you can be sure the force is along the normal. So if you put some amoeba shape like this in a fluid, the force will be perpendicular to the surface. The force is always perpendicular. So we define pressure as is F perpendicular by surface area. Now pressure is a scalar quantity. Area is a vector quantity. So the direction is given by the area vector. I'll tell you what it means. Remember, area is a vector. A cross B. Remember, pseudo vector था वो. Area of a parallelogram. This is your definition. So this is what actually happens when you go under the water. If you ever been into a pool or if you ever gone for a little in scuba diving or something, once you go to a little depth of 10, 15 meters, you'll start feeling something is crushing you. Like you will feel a little uneasiness. It's not that comfortable. So that is what is happening. As you go more and more deep into the water, the molecules are colliding more and more rapidly. So this puts a lot of pressure on you. Same way, vice versa. When you're climbing a hill or something, and you go to an altitude of like 4,000, 3,000 meters, the pressure drops because the number of air molecules are less, collisions are less, the pressure is less. So end of the day, when you say pressure, you're simply talking about the molecular collisions with your skin or with your surface. At a fundamental level, it is the number of molecules colliding with your surface. And similarly, inside your own body, your blood is also colliding with the skin from inside. So this is called blood pressure. So generally, the blood pressure is equal to the atmosphere pressure outside, so you don't feel a thing. But when you climb very, tall hills and everything, right? And if you don't get acclimatized properly, and if you just start climbing, first thing that will happen, right? You will faint. And your nose, right? You'll start bleeding from your nose also, if you have ever happened to you. So normally when you go to this Leh Ladakh, right, for any time tourism or something, first thing they'll say, boss, you just come to the place and sit for 2 days and do nothing. You don't get down on day one and then you go for hiking or something. You will faint within few hours because there is a oxygen level is less, 70 to 80%, right? And you can also feel this in a plane, right? Your ears start ringing because in a plane the cabin pressure is around 0.85 p naught. It's little less than atmosphere. They don't pressurize the cabin to exact p naught. It's 0.85 something. So that is there. So this pressure, right, doesn't have a direction. So when you say pressure is P at this point, so what the pressure tells you is if this was an area vector dA1, then the force will be F1, which is P into dA1. Think of like this. Listen to this statement. Whoever comes towards me, I'll push you away by 1 meter. So if you come from the front, how will I push you? I'll push you away like this. If you come from the right, I'll push you to the right. If you come from the left, I'll push you to the left. Are you getting it? So the direction doesn't depend on me. The direction depends on how you come, na? Whoever comes towards me, I'll push you away with 1 meter. Now, which way will I push will depend on how you are coming. So pressure itself doesn't have a direction. It depends on the area vector. Suppose if you take area vector like this, dA2, then the force on this small area will be pressure into dA2 this way. If you take dA3 like this, so the area vector will give you the direction. The pressure itself doesn't have anything. Is that making sense, everyone? And then we have units. The SI unit is 1 Pascal. 1 Pascal is 1 Newton per meter square. Then we define something called 1 atmosphere pressure. Symbol is P naught, which is 1.01 into 10 power 5 Newton per meter square. That's actually a pretty huge value. We don't realize this. We take a 1 meter square ka sheet, and if you apply the atmosphere pressure, that is 10 power 5 newtons, that's almost 10 tons. The reason you don't feel this is because there's atmosphere on both the sides, it cancels out. You don't feel a thing. But that's a huge amount of pressure actually. We'll see about that. Right? Take a break, come back by 7 and we'll continue from here. Any doubt so far? Okay, come back in 10 minutes. Let's see. Chalo, cams on everyone. Let's see. So this atmospheric pressure, right, which is P naught. Now, sometimes you'll also see they'll give you this in terms of mercury column length. You'll see this generally in chemistry. So they can also write P naught as 76 centimeters of mercury column. So meaning of this is, so when you say 76 centimeters of mercury column, it is rho mercury GH. We will see later on why does this come from a barometer thing. G is 9.8 and this is 0.76. So if you do this, you will end up with actually around 10 power 5 Newton per meter square. So sometimes they'll give you like this. They will say the pressure is 10 centimeters of mercury column. So then you have to convert this length into pressure. So this is rho mercury G H. So this will be 13,600. 9.8 into 0.1. They can even give you like this. Pressure P is, let's say, 3 meters of water column. So you can even change the liquid. That means this will be rho is 1000 and G 9.8 and water is 3 meters. Making sense? So they will not tell you in pascals. They will tell you it is 3 meters of water column. So you can get it from there also. And then we define something called gauge pressure. So gauge pressure is actually the actual pressure minus atmosphere pressure. This is the pressure you will see on your, vehicle car ka tires ka pressure, vehicles ka pressure and all that. It's a pressure with respect to atmosphere. This is another terminologies you see. So example, if someone says gauge pressure is 5 atm. The actual pressure will be 6 atm. Clear that? So this atmospheric pressure, right, can be really huge. It doesn't feel that way because day to day it cancels out. So you feel it is nothing, but let's see how deadly it can be.
And it's part of the Year 9 science curriculum. Is what we're going to do is we're going
Able to hear, right?
we're heating up a little bit of
So what the teacher is doing here, they took a metal drum, that's an oil ka metal drum, and they kept some water inside and they're heating it. So when they're heating it to high temperature, what happens? The water will become steam. So all this steam, right, pushes the air outside of that. You can see the steam gushing out from that hole.
And as we heat the water up, it changes phase.
So what they're doing, right, they're making sure there is no air inside. The entire thing is filled with steam.
From liquid to gas, and that
You can see the steam coming out. So now they're removing the heat and the teacher is going to seal it up. There, they'll close the metal thing. Now see what happened. Inside there is no air. It is completely filled with steam. So now if this thing cools down, what happens? If you start cooling down this, the steam will condense into water. If the steam condenses into water and if there's no air inside, you start getting a partial vacuum, right? So the pressure inside will start dropping. You can actually try this with a Coca-Cola can, tin can. It works, right? So inside the pressure is becoming almost zero and outside there is an atmosphere. So let's see what happens. You can leave it, but to make it faster, they're going to put some water.
Stand your ground, friend.
That's what an atmosphere pressure can do. So this is not called an explosion, it's called an implosion. An explosion, right, explodes outward. This implodes inside. Right? You might think like, oh, chota drum se kya hoga? So there we can get a bigger one. Where is this? Hmm. There, this is nothing small. This is the petrol tanker which the trains carry, remember? Same thing now. If you remove all the air from inside, what happens? That's a proper metal thing, huh? Just look at that. It just literally gets crushed. That's what an atmosphere pressure can do. That's what I said. For every 1 meter square, there's a force of 10 tons. We don't realize this because the pressure cancels everywhere. But inside, if you have vacuum, this is what will happen. There. Now you have some respect for atmosphere. Yeah. Great. Let's see. Let's go ahead. Let's see a few more questions. So we have a wall here. Wall is moving with speed v. This is the velocity of the wall. Coefficient of restitution is z. We have a water jet. We have done something similar like this in variable mass system. Density is rho. A is the area of cross section. So this water jet goes and hits a wall which is moving towards it, and E is the coefficient of restitution. The second case, we have a wall, E is equal to 1. The wall is at rest. This time the jet is going to hit at an angle and bounce off like this. This is theta, theta. This is your velocity, rho, and area. Find the pressure on the wall. Due to the water jet. How do we do this? Pressure, Ray God, what are you finding? Dimensions are even matching. Let's see the first part. How to do these kind of questions? We have done this in variable mass system. So first thing, when the wall is moving, stop the wall. solve with respect to the wall, because it's an inertial frame. Wall is going with constant velocity. There is no acceleration. So the observer will think the jet is coming with u plus v. Agreed? If you stop the wall, you think you're coming with u plus v and you hit the wall. If you hit the wall, you'll bounce back with what speed? E times u plus v. Head-on collisions, everyone. If you hit a wall with speed u, you'll bounce back with e times u. Then what we do? Take a small piece, dx. So this mass of the small piece, dm, will be density into volume, which is a into dx. So the change in momentum of the small piece, dp, is 2 times dm into v final minus v initial. In this case, it is dm into v plus u into 1 plus e. Force, Newton's second law, dp by dt, which is rho a dx by dt, v plus u into 1 plus e. This will be rho a v plus u whole square into 1 plus e. You want pressure? So pressure P will be force by area, which is rho into v plus u whole square into 1 plus e. There, that's your answer. E is not equal to 1. I gave it as e. So if you put e is equal to 1, then you'll get 2 times. So this is a head-on collision. What about this guy at an angle? E is equal to 1, wall is at rest. This is a good one. You can put a star for this. Again, you'll encounter this question in modern physics. But any doubts on the A part, please ask. Yeah, what would be the second part? Try, I'll give you a minute. That's a good one. How did you get v plus u into e plus 1? Change in momentum? V final minus v initial. This minus of this, right? Minus of minus, isn't it? No, this is I cap. This is minus I cap. So minus of minus तो add हो जाएगा ना? Sure, na? Yeah. What about this thing at an angle? Right, Vihan. See, the B part, E is equal to 1. This is theta, this is theta. Now see, you're hitting with speed u here. You're bouncing also with speed u here. So if you see the change in momentum will be only in the horizontal direction. So this is dx. So we have dm is density into area into thickness. The change in momentum, it will be only the horizontal direction, which is 2 dm u cos theta. Do you agree with that, everyone? Only the u cos theta component will reverse, u sin theta component doesn't change. So there is only change in momentum in the horizontal direction. Is that clear, everyone? Sure, no, Parth? Clear. And then the force will be dp by dt 2 into rho a dx by dt into u cos theta. So force part so far is fine, 2 rho a u square cos theta. Now this is where the mistake people do. They think pressure is force by area. Not wrong, but which area are you talking about? The problem here is the area is not A anymore. Look at this. When the water jet is coming at an angle, when you extend this, notice this, what happened. This water jet is actually spreading over a bigger area, isn't it? The water jet is not hitting an area A, it is hitting a much bigger area. If you take this as area A, this was theta, this was theta. This guy is actually hitting an area of A by cos theta. The water jet spreads. To be more precise, you know what actually happens? If you see the cross section, initially it is circular, right? If this was radius r and this was radius r, you'll observe only in this direction it is stretching, na? So it actually becomes like this. It becomes an ellipse. So one side becomes r by cos theta. The other side still remains r. Are you getting how it is? Think of like this thing. If this was the area, when it is going and hitting here to the wall, we are talking about this area. So this one is stretching, na? Whereas this line here will still remain same. Is that making sense? It will stretch in one direction, the other one will remain same. It is not spreading out in the horizontal direction. Sure, everyone. So this area becomes A by cos theta. So the pressure is force by area where the force is acting. It's not the area of cross section of the water jet. So pressure is force by A by cos theta, which is 2 rho u square cos square theta. You'll get cos square. This actually becomes an ellipse from circle. So this is the area where force acts. So A is not the area of cross section. Previous case it became, but it's not true every time. Clear? Right now, again, so if you look at a water jet, ever heard about this thing? There is something called water cutting. If you can take a highly pressured water jet, right? If you make it into thin stream, you can actually cut even metals. Meaning, look at this pressure here. We are getting a pressure of almost 2 rho u square. Chalo, if you just assume it is just passing through rho u square, if you take water, rho is 1000, and if you can hit with a water jet of, let's say, even 50 meters per second, that is 2500. We are talking around 25 atmosphere pressures. Right? If you can put 100 meter per second, you'll get 100 atmosphere pressures. You can even cut through steel. So normal welding, right? What happens? You use heat to cut it. So this will melt the edges. But if you use a water stream, right, you can get a pretty neat cut. Kind of like this. That's a metal lock and that's a water jet. It just slices through. You can see more clearly now. See? Neat cut. Now, when you see that, you're getting a feeling now. What happens if I put my finger inside? Happens. General feeling people have. So someone did think about that. Now we don't actually put human ka hand.
Is running. There's a weird primal urge to swipe your hand under it. As fast
So
as you
they
can.
made an
How
artificial.
bad it would hurt.
Would be a slight score. What shall know?
Through a series of
So they made some hands or some material. So the bone one, the hand one, and
three
everything.
ballistics gel hands through a series of tests, and then we're gonna X-ray them. I'm quite
So let's see what happens if you keep this through
skin
water.
pattern on these. This poor specimen here. Sure, the sauce. For the swipe.
Imagine I was adjusting something on the jet and accidentally slipped and went.
Yeah. Or you gave in to the primal urge and you just, you risked it all.
You risked it all.
Interesting.
There.
I wonder how that got out there, but
Well, you'd be missing
And there. The bone will get chipped off. That is how bad it will be. So don't put your hand under a water jet.
the
It's a
tip
very bad
of your
idea.
finger. The bone would still be there.
for the most part, it even took a little chunk out of your bone right here. But your flesh would most definitely be either hanging off or gone.
Gonzo bean.
I just
Just a movement. That's enough to
Let's
just
say
slice
you
through.
fell asleep with your hand on the cutting table
correct. That
And
happens all the time.
all the time.
All the time.
I'm always getting drowsy.
It
out
should
here.
not be sleeping there.
Move. And we'll see
Now
if
see,
that-
they're just pushing through the middle of the hand.
Oh,
There.
that's some damage.
Yeah, don't be drowsy while working a water jet, people.
Yeah.
It almost goes through the bone.
That's bad.
Rips the flesh off. So
There. Now you have respect for water jet. So don't put your hand under a water jet. Pretty bad idea. It will just slice through. Right. This thing, right, is also used in hydro destruction. For example, look at this thing. Especially used for reconstruction of roads. When you have an old road and you have to remove that and make a new road, you need to remove the first all the concrete layer on top of it. The technical methods of using this hammer, cranes, and all won't work. So look at this thing, how it works this way. Can you see how that entire concrete is chipped off? Only the metal is left over. So you have just enough pressure to beat the concrete, but not the metal. So you can remove all this concrete from there. This is called hydro destruction. That is one. And if you see in our Bollywood movies, they show there is a building on fire. Hero comes with a fire engine. He takes 2 pipes and starts spraying water on the building. But if you actually go and see a fire station thing, right? 2 firemen catch the pipe actually. It exerts so high force, 2 people need to catch. This happened once in 2015 or 14 in Thane, right? There is an old building on fire. These people came and they started spraying water. The force was so high, the pillars cracked and the building collapsed. So the fire engine water jet really exert a high force. So you can even do things like this. You can see the water jets. You can see that. So each water jet is giving a force of rho a v square. So 2 into rho a v square. That's equal to the weight of the man. So this is what I'll actually have enough force to lift a man. You will find this kind of thing in Dubai or something. Don't try this in India though. There, he's catching 2 people there, see. So this thing does have enough force. There, so that's how water jet works. it does have enough force, and if you can make the water jet thin, you can have enough pressure to cut through steel also. Clear, everyone? Great. Next thing. Now let's see how does pressure vary in a fluid. Variation of pressure. Consider an imaginary cylinder. Inside the liquid. With points A, B, C. So consider one cylinder here, consider one cylinder here. So if you consider a point A here, if you consider a point B here, if you consider a point C here, let this height be HA, let this height be HB. Now, if you consider an FBD of this cylinder here, the vertical one, like I said, it's all FBDs here. So force from the top will be pressure and A into area. Pressure from the bottom is PB into area. So this difference in pressure is balancing your weight. So if you write the equation here, you will end up with PB minus PA into area is equal to mg, which is nothing but density of the liquid. Area into volume will be H2 HB minus HA. Volume of a cylinder is area into the height into G. So from here we get PB minus PA is rho G HP minus HA. So you can clearly see this form. dP is equal to rho G dH. This is your differential form. So this is nothing but change in pressure for a small dH height. So use this whenever you have to integrate. Now, from the equation, if you take A on the surface, so if you choose the point A is on the surface, then the point A is exposed to atmosphere. Then we get HA becomes 0 and pressure at A becomes P naught. Then your formula becomes PB is equal to P naught plus rho G HP. There, so this gives you a general formula. So pressure P is equal to P naught plus rho G H. So this is the pressure at a depth H. But remember, there's a catch. This is valid only when rho and G are constant. If density or gravity changes, you can't use this. Then you have to integrate. And H is what? H is the depth from the surface. So P is the pressure at a depth H from the surface. So the differential form is more powerful. Whenever density or the gravity messes up, use dP is rho G dH. But if rho and G are constant, we can use the rho G, P naught plus rho G H. Yeah, have a look at this. Yeah. Let's see. Now, if you take a horizontal cylinder, So this will be PB into area. This will be PC into area. If you see, there is no acceleration horizontally. So we get PB is equal to PC. So from this, we can make a statement. The pressure depends only on the vertical height. Or you can see pressure varies only in vertical direction. It remains constant in horizontal direction. Now here comes a small issue there. What is vertical? When you say up and down, what is up and down? We had this discussion before, but what is again up and down? Quite an important thing. What is up and down? This is up and this is down. That's not how we define that. If you say up and down like that, means for people in the North Pole, this is up. For people in the South Pole will walk with their heads, isn't it? So what is up and down exactly? I taught you this in circular motion. Up and down is the direction of net force. Getting it? If you remember for Earth, the net force is towards the center of the Earth. So center of the Earth is down, that is up. Getting it? So the whole concept of up and down depends on the direction of net force. So the direction of the net force is taken as vertically downward direction. Direction of net force is vertically down. Be careful while taking the net force, include pseudo force. Let me show an example. For example, let's say we have a container. Filled with liquid. If you consider the points here, 1, 2, 3, 4, 5, 6, 7, and 8. So this is at rest. Gravity is there. So which point will have the highest pressure? Now here, what is down exactly? So here down is the gravity direction. So this is your down. And automatically this becomes the horizontal. So if you look at the order here, the 5 is the pressure is maximum, P5. Then comes 6 and 4 are equal. Then 7 and 3 are equal. Then 2 and 8 are equal. Then 1. Agreed? But let's say the same thing. If you take this, and let's say this time you're accelerating horizontally with A equal to G. And gravity is also there. Now if you take point 1, 2, 3, 4, 5, 6, 7, and 8. Now can you tell me what is down here? Now if you try to draw the pseudo force, this is MA, which is actually mg, and this is mg. If you see, your down is actually passing through 2 and 6. So this system will think this is down and this is horizontal, the green lines. Is this making sense, everyone? If you remember, this was what happened in the beginning, right? The liquid is at an angle. Why did the liquid even make a turn like this in the beginning, if you remember this question? So in this question, right, the liquid thought this was down. No? That's the reason the liquid surface was perpendicular to the horizontal. Right? It's basically parallel to the horizontal there. So this is how it would look. So And the system will think this is gravity now, which is G effect F, which is root over A square plus G square. In this case, it is G root 2. So you tell me which point is the highest pressure? Where's the highest pressure now? 6. Then comes 5 and 7. Then comes 8 and 4. Then comes 3 and 1. Then comes P2. Did you see the whole order changed? So if you accelerate this container, suddenly 2 to 6 becomes vertical. Initially 1 to 5 was vertical. So the whole concept of what is up and what is down will depend on what is your net force. Is this clear, everyone? Have a look at this example. This itself is a question at a mains level. Yeah? Great. Next thing. Let's say a question on this. Let's say we have a container filled with liquid. It's accelerating with A. Let this be length L. Let this be height H. Accelerating with A. This is point A. This is point B. And there is also gravity. Find PB minus PA. Then show the liquid is rho. Now here's so what we can do, consider you take a cylinder here like this and consider a cylinder like this. So consider a new point here. Let's call it C. So when you take the horizontal cylinder, you can use FBDs. This is P into area. This is PC into area, right? And PC into area minus P into area. This is acceleration, which is mass into acceleration. So PC minus PA into area. What is mass? Rho. Area, length of the cylinder into the acceleration. So A gets cancelled. PC minus PA is equal to rho L. You can do like this, or there is even a faster way. When you go from A to C, the pseudo force A will be this way. So doesn't it behave like an acceleration in the horizontal direction? So when you go from A to C, only A will matter. When you go from C to B, only G will matter. Is that making sense? So when you go from A to C, it feels the gravity is A. And when you go from C to B, it feels the gravity is rho GH. You can just add them. You will get PB minus PA is rho LA plus rho GH. Pretty good question at a mains level. Now, some people have a doubt. Sir, why are you not taking G effective here? The problem with G effective here is, if this was A and this was B, is there any guarantee this MA and this MG will pass through AB? There is no guarantee it will pass through, right? So it would look something like this. This would be the G effective. That means this is down, na? So कैसा calculate करना पड़ेगा? You need to drop a perpendicular from B to here. Then you should take this distance, isn't it? Are you getting the problem with that? There is no guarantee the G effective will pass through AB line. You should do something like this sort. You should take the length of this green line and then do rho G effective into that whatever is that distance. So it doesn't work that way. It is not that, but this is safer. You can just travel horizontally. When you travel horizontally, only A will matter. When you travel vertically, only gravity will matter. So separate the problem into two pieces. Sure, everyone. Any doubts on that part? Okay, next one. So we have a vertical circular pipe. Filled with two liquids. Rho 1 and rho 2, which fill up, which occupy quarter of a circle. Pressure is a scalar, God. Which occupy quarter of a circle. So you filled one liquid here. Let's say this is one liquid here. (90°). Let's this be rho 1. The second liquid is here. This is another 90°. This is rho 2. So since rho 1 is denser, that will occupy the lower part and the red will get pushed up a bit, isn't it? And this angle is theta. System is in equilibrium. Gravity is there. Find rho 1 by rho 2. Let me tell you a few points here. First thing, how do we guess this? If this comes in the exam, how do you guess this? That is the first thing. When I see this question, rho 1, rho 2, theta, all are variables. I will not think about solving the question. I'll think like, yeah, I can guess this. For example, if rho 1 becomes equal to rho 2, what happens to theta? If rho 1 is equal to rho 2, how will the liquids look like? Half of this will be black. The second half will be red, isn't it? Theta must be 0. So if you put theta is equal to 0 in the options, rho 1 by rho 2 should be 1. Makes sense. What else can I do to guess? But this will not eliminate all the options. This will be still stuck with 2 options. Anything else that we can guess? For example, if rho 2 is 0, means what? If rho 2 is 0, what will happen? There is no liquid, right? Rho 2. That means this black one will occupy half here and half here. So this is 45. This is 45. So this is 45. Theta must be 45 now. So you put theta 45, rho 2 must be 0. Does this make sense? You can guess like that. But how do we solve this? Remember we wrote in the beginning, pressure depends only on the vertical height. So I really don't care what the shape of the container. See, I can take some weird amoeba shaped container like this. And if you ask me the pressure from here to here, the pressure at this point will simply be P naught plus rho GH. It doesn't matter what is the shape of the container. Why? See, I can prove you that. Listen. Let's say from here to here, if I go down H1, what is the pressure? P naught plus rho GH1. If I travel horizontally, pressure will not change. Then if I go down again, pressure will change by rho GH2. If I go horizontally, pressure won't change. If I go down again, pressure will change by rho GH3, rho GH4. So the total pressure will be H1 plus H2 plus H3 plus H4, which is H. Is this making sense? You take any shape of the container, I don't care. The pressure will only depend on the vertical height. So using this logic, can I say like this? At this bottommost point here, A and B here, pressure must be same. So what you want is this. You want this vertical height, let's call it H1. You want this vertical height, let's call it H2. And you want this vertical height, let's call this H3. Isn't it? Then you can find the pressure on the left-hand side and the pressure on the right-hand side, and both should be equal because it is in equilibrium. Is this making sense? Can you find H1, H2, H3? Finish off. Now it becomes a geometry problem. So the first thing is to figure out, it doesn't matter on the shape of the container. Look at this red one. For the red, I'm only interested on this height. I don't care about the actual shape. So get the heights. Get it. I'll give you a minute or two. Anyone didn't get the question, please ask me. Right behind. You can simplify that further. Just divide everything by tan cos theta. So if you look at this thing here, so consider this point A here and this point B here. Since they're at the same level, PA must be equal to PB. So if that is theta, this is 90 minus theta, this is theta, and this is 90 minus theta. So if you look at this side here, that is r sine theta. So this is r minus r sine theta. This side will be r minus r cos theta. This height will be r cos theta. This height will be r sin theta. Hope everyone is getting that. Check it out. It's just geometry there. So pressure on the left hand side PA, that will depend on rho 1, the liquid. This is rho 1. G, the height is r into 1 minus sin theta. Whereas on the right hand side, the pressure rho 2, G, the total height of the red liquid is r sin theta plus r cos theta plus rho 2 G r 1 minus cos theta. There. So the total pressure because of these two liquids must be equal to the pressure due to this rho 1 liquid. Is that making sense, everyone? GR cancels everywhere. This will be rho 1, bring it this side. This will become cos theta minus sin theta. This will be rho 2 cos theta plus sin theta. Divide them. You'll end up with rho 1 by rho 2 is 1 plus tan theta by 1 minus tan theta. There, as expected, if I keep theta is equal to 0, I'm getting equal. If I put theta 45, I'm getting denominator 0. Check out the steps. So the first idea here is the pressure depends only on the vertical height. I don't care about the shape. And second thing, you just, meaning that is the main thing actually. Then you just find the length here using geometry and finish it up. Have a look at this. Ask me if you're confused. Yeah. Great. Okay, that's the last one for the day. So that will wrap up for the day. When we catch up on Thursday, we'll continue from here. We will see R naught hoga na equation mein. What is R naught?
So rho
Rho
1
naught.
होगा ना
Where
rho 2
इसका
हाँ
I did a mistake. हाँ भाई I remember it as rho 1. I wrote it as rho 2. Correct. I shifted that side. So Thursday when we catch up, we'll continue from here. We will see more variations of this. We have much better problems coming up. So this is like a basic part of it. Okay, that will wrap up for that. Now heat and thermo is done. So please make sure to complete the whole thing, right?